Hi everybody and welcome again to Campbell's Math Corner. So today we want to look at factorization. Now first of all, factorization is a reverse process of expanding. So in algebra sometimes you're asked to expand and simplify, where we use the distributive property to multiply each term inside the bracket by the term that's directly outside. Now factorization is actually the reverse of that, where we actually try to get the expression within a bracket. So we factorize a set of algebraic terms by expressing them as a product of some of their factors. When we use a distributive law backwards, we are said to be factorizing. As such, ax plus bx is going to be equal to x, which is the common factor, and that would be a product of a plus b. So x and a plus b are said to be factors of ax plus b. So that's pretty much what we mean by factorizing or factorization. Now there are different factorization techniques or factorization or methods of factorization, so to speak, and we basically we hope to complete all four. So the first one we want to look at is the highest common factor. Now, take for example we have x squared minus 3x, which means x is being multiplied by itself minus 3 multiplied by x. Now if we look at the two terms, we realize that x is common to both terms, and as such that x is going to be the common factor that we are going to use to factorize this expression. Now since x is a common factor, we factor out the x. That will leave us with x minus 3 inside the bracket. And remember we said that factorizing is the opposite of expanding. So we can always check to see if our answer is correct by simply apply the distributive law and see if we'll get back our original answer. And of course x times x will give us x squared, and x minus 3 will give us minus 3x. Alright, so feel free to pause the video and try these. Alright, so if you have actually given these a try, I'm hoping you realize that the x is common factor here, which means that x, and in brackets we'll have x plus 4, and again you can check by simply using the distributive property and see if you'll get back the original expression. So x times x will give us x squared, and x times positive 4 will give us plus 4x. Now the next one, now some persons will be tempted to say that the common factor is x, which is true, but remember we want the highest common factor, and in this case the highest common factor is actually x squared. So x squared, and in bracket we will have x minus 3. Now again you can check by simply multiplying the term outside by the term that's inside. So x squared times x will give us x to the third power, and x squared minus times minus 3 will give us minus 3x squared. If we look at this one now, we realize that 4 is actually common to both terms. Variables are different, so no variables are common here, so it's just a 4 that's common. So it means that outside we'll have 4 and inside we'll have x minus 3y. And that's pretty much it for factorizing using the common factor. And this is pretty much the simplest form of factorization. Alright, so let's move on to grouping in pairs. Now let's say for example you're given this expression to factorize: xy plus y plus 2x plus 2. Now sometimes you'll notice that there may not be a highest common factor for all the terms in an expression, for this, like this one for example. But if you notice, although one is the highest common factor for all the 4 terms, by pairing or by grouping the terms in pairs, we realize that for the first 2 terms we have a common factor of y, and for the last 2 pairs, or the last 2 terms, we have a highest common factor of 2. And as such, we can factorize by grouping in pairs. Now what do we mean by that? So the first thing we want to do is regroup the terms such that each pair has a highest common factor. Then we extract the highest common factor from each pair. So as we mentioned, the highest common factor for the first pair would have been y, and factoring out the y will leave us with x plus 1. And then for the second pair, 2 is the highest common factor, so we factor out the 2, leaving us with x plus 1. Now what you realize is that we have common factors here, which is actually x plus 1. So our solution then will be the common factor, which is x plus 1, and what's remaining, which is y plus 2 inside another bracket. And that's pretty much it. So normally you can tell when you're supposed to factorize by grouping in pairs. These expressions normally come in with 4 terms. So by looking, you'll realize that such an expression would be required to factorize using the grouping in pairs. Now it's important to know that the order that the terms in the brackets are written doesn't matter. So if you wanted, you could have written the y plus 2 first, followed by the x plus 1. It really doesn't matter. And of course, you can try these on your own and see if you get the correct solution. Feel free to pause the video and try. Alright, so if you have actually tried these by grouping in pairs, well, the first 2 terms have a common factor of x, so we can factor out that x, and that will leave us with x squared plus 4 inside the bracket. And for the second pair, well, the highest common factor in this case is only 1, and nothing is wrong with that. And then you'd realize that you will end up with common terms inside the bracket, which means that these 2 terms here are common factors. So again, to write our solution, write the common factors, and then what's remaining we put inside another bracket, and that's our solution. So that's our product of factors. Now the next one, highest common factor here for the first pair of terms is actually x squared. So if we factor out x squared, that will leave us with 2x minus 1, and then since 5 is the common factor here, then we factor out the 5, and of course that should be a negative 5, because you want when you multiply back the negative 5 times 2x, you should be getting negative 10x. Hence we use a negative 5 outside the bracket. So again, the common factors there will be 2x minus 1, and then what's left will be x squared minus 5. So again, once you understand the basic of using the highest common factor, then you realize that factorizing group is pretty much similar. All you have to do is organize the expressions or the terms in pairs and then factorize using the highest common factor. So that brings us to our next method, which is the difference of 2 squares. No. The difference of two squares is pretty much easy as well. Now by expanding, we know that we are actually using the distributive property, and we said that we can always, we said that factorizing is the opposite of expanding. Now look at this example. We have x squared minus 9. Now the terms, the key terms here are the difference and two squares. Now if we know what difference means as it relates to maths, then we know that is a minus or a subtraction sign. And two squares, where we look at the two terms here, we have an x squared and we have a 9. Now if we know anything about squared numbers, then we know that x squared can be written as x squared, and this 9 can be written as 3 squared, because x times x will give us x squared and 3 times 3 will give us 9. Now, given an expression like this to factorize, what you would realize, or what you would notice, is that you will end up with, again, two brackets, and inside the brackets, the first bracket, you notice you have x, which is actually the square root of x, and 3, which is actually the square root of 9. Now the only thing that's different in the two brackets is the signs. Now one is going to be positive and one is going to be negative at all times, and it doesn't matter which one you make negative and which one you make positive, as long as you make one positive and one negative. So x squared minus 9 is the same as x plus 3, x minus 3. And here's another example. So 4x squared minus 25y squared. Now again, by looking, you should realize that, well, I'd hope you'd realize that 4x squared can actually be written as 2x all squared, and this 25y squared can be written as 5y all squared. So if we should square 2x, we will get back 4x squared, and if we should square 5y, then we'll end up with 25y squared. So again, our solution will be our two brackets, and we use the square roots. So we have 2x minus 5y in one bracket and 2x plus 5y in the other bracket. So again, the key to factorize using the difference of two squared is just to identify if there is two perfect squared numbers, and there must be a minus sign between those two. If there's not a minus sign, then it cannot be factorized using the difference of two squares. Alright, so feel free to pause the video and try these. So if you had actually tried these, then, well, the first one, straightforward. We know that we can square 9 to give us 81, or the square root of 81 is 9, and the square root of y squared is actually y. So then our answer then will be 9 plus y, 9 minus y. Next one, square root of 4x squared, that's 2x, and the square root of 9, that's 3. So a solution then is 2x plus 3, 2x minus 3. Now look at this third one. So at first glance we said then, well, there's a minus sign between the two terms. However, we realize that this 3 is not a perfect squared number, and this 12x squared is not a perfect squared number. But if we go back to factorize using the highest common factor, then we realize that 3 is a common factor. So it means then that we have to factor out this 3, and that will leave us with 1 minus 4x squared, which now looks like a perfect, well, a pair of perfect squared with a minus sign between it. Because if we find the square root of 1, that is actually 1, and the square root of 4x squared is 2x. So it means then that this can be factorized as the 3 that we factored out earlier, and the 1 plus 2x, 1 minus 2x, which comes from the difference of two squares. Next one, we'll square 3x, and that will give us 9x squared. So, and 16y squared, the square root of that will be 4y, and as such we'll have 3x plus 4y, 3x minus 4y. Now, I hope this last one didn't catch you, because it said that what x squared plus 4. So even though we know that x squared is a perfect square and 4 is also a perfect square number, remember we also need to look at the sign that comes between them, and in this case it's a addition sign, so it means that this cannot be factorized using the difference of two squares. As a matter of fact, it cannot be factorized. So that's pretty much it for factorize using the difference of two squares.